Hello everyone, Snake here, and in today's video we are going to take a look into the world of binary arithmetic. Now, in today we are going to focus on addition and subtraction. I'm keeping multiplication and division for a separate video. Okay, so let's get started. So one thing I missed out in the previous video is the idea of the number line. Okay, so first let's draw a number line here. Okay, this will be 0, and from here we go say 1, 2, 3, 4, and so on. Okay, now when we represent these numbers in a different base, let's say we are taking the binary base system. Okay, this will be 0, and on the number line 1 will be 1, 2 will now become 10, 3 will become 11, and 4 will become 100, and so on, like this. Now the thing to observe here, the thing to note here is that you see the numbers are the numbers. What I mean is that the properties of the number will always remain the same irrespective of a base. 3 will always be an odd number, it will always be a prime number, it will always be an integer. Just because you change the base of it, it will not change those properties, it will forever retain those properties. Okay, it is just that we are representing 3 in the form of 11 here in the binary system. That's all it is. The numbers will behave as the numbers intend to behave. Okay guys, with that out of the way, let's move on with arithmetics. And first we are going to look in the base of 10 and then move to the binary system. Okay, now to start off, how were we taught in school to do addition? Okay, it was basically like we take two numbers, say 15 and 12, and to add them up we consider the digits in each places and we added them up. Let's say first we consider the units place and we added them in the form like 5 plus 2, that would give us 7, and then we move to the tens place where we see 1 plus 1 would give us 2, and hence the sum of 15 and 12 is 27. But the point is that we were never taught what happens under the hood. Okay, let's see what actually happens. First we expand 15. Okay, that would give us 1 times 10 plus 5 times 1, and now we expand 12. Okay, 1 times 10 plus 2 times 1. Okay, now since we are doing the addition process, let's arrange them in an addition fashion. Okay, 1 times 10 plus 5 times 1 plus 1 times 10 plus 2 times 1. Okay, now let's take the tens commons. So what do we get? We get 1 plus 1 times 10, and then we take the ones place common. Okay, that would give us 5 plus 2 times 1. Okay, so the result we get is 2 times 10 plus 7 times 1, which is basically 27. That's the process, and that's what happens under the hood of addition process. Now with addition there is another case to consider, the case where there is a carry. So to see that, let's take two numbers. Okay, say 17 and 15, and first we check the units place. We see that it gives us 7 plus 5 12. So what we do, we place the 2 here and we carry the 1, and now we move to the tens place where now there are three numbers, three digits, and we add them up, and that gives us 32 basically. So what is actually happening under the hood? Let's do the same thing as we did before. Let's expand both numbers. Okay, 1 times 10 plus 7 times 1, that is 17, and then for 15 we get 1 times 10 plus 5 times 1, and now we are going to take the tens and the ones common. Okay, so that would give us 1 plus 1 times 10 plus 7 plus 5 times 1, which would finally give us 2 times 10 plus 12 times 1. But you see 12 here can be further expanded. Okay, so let's continue to expand it. this would now give us 2 times 10 plus, let's take a bracket here, 1 times 10 plus 2 times 1 and a total multiplied by 1. Okay, and let's continue. 2 times 10 plus 1 times 10 times 1 plus 2 times 1 times 1. Okay, so now we are going to take the tens commons again. Okay, so this would give us 2 plus 1 times 10 plus 2 times 1, which finally gives us 3 times 10 plus 2 times 1, which is 32. You see here, the carry that we are doing here is actually this step, this here, that we are splitting the 12 and then we are taking the 10 and combining it with the 2 here. Okay, this is what actually happens when we do arithmetic carry here. Okay, guys. Now with that, let's move on to binary addition. Okay, now there are 4 rules to know to binary addition. That is, 0 plus 0 will give you 0, 1 plus 0 will give you 1, 0 plus 1 will give you 1, and 1 plus 1 will give you 10. Oh, don't worry, this is just basically in the base of 2. Don't worry, maths is not broken. Okay, so let's apply this, let's put it to use. Okay, let's take two binary numbers, say 1011 and then 1001. Okay, to add this, just simply use these rules here. Okay, that would be 1 plus 1, that would give us 10 here, so 0 goes here and the carry goes to the top, and in the tens place here this would be 1 plus 1, that would again give us 10, and then in the hundreds place there is only 1 remaining here, so it will become 1, and finally in the thousands place it is 1 plus 1, that would basically mean 10. And this is how you do binary addition. Okay, just remember these rules, and there is nothing to memorize here. This is basically just the number line here that I showed you before. Okay, 0 1 2 3, this is in binary will simply be expressed as 0 1 10 11. This basically is just simply going from 1 then to 2. 2 is basically 10, that's all. This is how you do addition. Okay, let's get on with subtraction, and this will be a tricky one, but we are going to go through it case by case. Okay, to start off, we are going to see the most simplest case where the top number is larger. Okay, let's take two numbers, say 17 and 5. In order to subtract it, we consider the units place. That would give us 7 minus 5 2, and the tens place will leave us 1, and the final answer will be 12. To understand this, let's expand it. Okay, 1 times 10 plus 7 times 1, and now in this case the 5 will be minus 5 times 1, and now we are going to group them. This would give us 1 times 10 plus 7 minus 5 times 1, and this will finally give us 1 times 10 plus 2 times 1, which is 12. Now, always remember the number line that I showed you. It is a very helpful tool to visualize. Okay. Okay, guys. Now we are going to look at the second case, the case of borrowing, where the top number is small. Okay. Let's take two numbers, say 25 and 7. Okay. To do this, we turn this into 15 and we cut 2, or we borrow from 2 and turn it into 1. So this result will give us 8, and the 1 comes down, which is the final answer, that gives us 18. Okay, to understand that, let's expand it. Okay, so from this we get 2 times 10 plus 5 times 1 minus 7 times 1. Okay, now we are going to do a little trick here. we are going to split this 2. Okay, so this would give us 1 times 10 plus 10 times 1 plus 5 times 1 minus 7 times 1. Okay, and now we are going to group them. 1 times 10 plus 10 plus 5 minus 7 times 1. Okay, and that would finally give us the result 1 times 10 plus 8 times 1, which is 18. See here, the borrowing that we are doing here is basically this. This is what happens under the hood when it comes to borrowing. Okay, the where we turn it into 15. See, this is what 15 becomes, and then we are subtracting 7 from it. And we are borrowing that 10 from the 2 by splitting the 2 here. This what happens under the hood basically. And now we are going to look at the final case where in borrowing there is a 0 ahead. Okay, let's consider a number, say 105, and we'll subtract 7 from it. Okay, so here we turn this into 15 and we borrow that 1 from this 0, but there is no number here. So what do? We cut 0 and turn it into 9, and then we cut this 1 and make it 0. Okay, and so finally we get, this will become 8 here and the 9 will come down, we get 98. Okay, so to understand that, let's expand it again. Okay, so this would be 1 times 100 plus 5 times 1 minus 7 times 1. Okay, now just like before, we are going to split this 100. Okay, now to split this, we are going to turn this into 9 times 10 plus 10 times 1 plus 5 times 1 minus 7 times 1. See what we did here? We took 100 and we split it down into 9 and 1 basically. What is it? It is basically 10 times 10, which is actually 100, and we are splitting this 10 into 9 and 1 basically. So let's group the numbers. Okay, so this would be 9 times 10 plus, and like before, 10 plus 5 minus 7, that would times 1, and finally this would give you 9 times 10 plus 8 times 1, which is 98. This is what happens under the hood for in case of subtraction. Okay guys, okay, with that done, let's move on to binary subtraction. Okay guys, and just like the addition one, there are 4 rules to it. Let me write those down for you. 0 minus 0, that will give us 0. 1 minus 0, that will leave us 1. 1 minus 1, that will leave us 0. And then finally 10 minus 1, that would leave us 1. Now you can understand this rule by using the number line that I showed you in the addition scenario. Okay, so let's get started. Let's take 2 binary numbers now. Okay, let's say 10011, and we take another one, 1101. Okay, let's subtract these 2 numbers. Okay, in the first case it is 1 minus 1, so that will be 0, and now we have 1 minus 0, that will give us 1. Okay, now in this scenario we have to borrow a 1. Okay, so we borrow a 1, but since this is a 0, we cut this down and we replace it with a 1, and then we finally turn this into a 0. Okay, now why we did 1 here, where in the decimal system we use 9 there? Okay, because you see the maximum number in the decimal system is the value 9. Okay, but in the binary system it is 1. That is why we are replacing here it with 1. You can again do the expanding process and apply it here as well, and you can see it for yourself as well. I'm not going to show it right now, but let's complete the subtraction. Okay, so 10 minus 1 will give us 1, and then 1 minus 1 will give us a 0, and finally the 0 will come down, and this is the final answer. Now this basically turns out to be 6 in the base of 10, but you get the process. This is how you do the binary subtraction. Okay guys, so guys, with this I end my video today. And please share your queries in the comments section. Please like and subscribe to my channel, and remember, to learn, never memorize. Bye guys.